The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, good afternoon, good evening, wherever you are in the world. Welcome to the DataView show. This is episode number 13. I'm Scott Hayes, your host, lifetime IBM champion, IBM DB2 Gold consultant. You can catch me on Twitter at SRHayes. Today I have a number of guests with us. We're going to be talking about a new way to think, updates on the Think conference with Colleen Biscotti. And we've got Data Science Masterclass and Hackathon news presented by Aylee Nielsen, who's an event program manager with the IBM Community. And she's also bringing along Austin Eovito, I think is his name.
That's right.
Right. Okay. Very good. So, Colleen, how are you today?
I'm doing great.
That's excellent news. We've had a few IBM executives on with us in the past, and it's fun to get to know them a little bit personally. Maybe you'd like to share something about yourself, hobbies, family, travel. What would you like the world to know about you?
So I'm a lifetime IBMer. I've been with IBM for 26 years, straight out of college, and have done a variety of different jobs. And what I've found over my career is that what I'm really passionate about is face-to-face events and interactions and creating those amazing experiences for attendees. And so I've been thrilled and excited that I've been in the role that I have now for about 7 years and always taking IBM events to the next level. I'm from Laguna Beach, California. So I love the outdoors and I love the beach, and I've got 4 kids that I enjoy it with.
Fantastic. I like the beach too. And Aylee, how about yourself?
I am calling in right now from sunny Florida, and it's beautiful, and I also love the beach. I get out on my paddleboard just about every day that the weather will allow it, and also a yogi, and I've been with IBM for about 6 years now.
Terrific. Both beach lovers, and you're on opposite beaches. We have the East and West Coast represented. Unfortunately for me, my closest beach would be Lake Travis. And on the scale of an ocean, it's just a puddle. That's fine. All right, let's giddy up, move along here. This is the Required Gibberish. The opinions expressed are that of Scott Hayes and the show guests and do not necessarily reflect that of IBM Corporation or the IBM community. DB2 is a registered trademark of IBM, which is also a registered trademark. We make no claims to any marks belonging to anyone. This event is being recorded and replays will be publicly available. Mind your manners. Everybody be friendly, be safe, wash your hands often. What's ahead? New way to think, news bits, data science masterclass and hackathon, ask a couple of polling questions, and then we'll wrap up. That's the plan. And here is Colleen Biscotti. Let's make you the presenter, Colleen.
Great. I will test my GoToWebinar skills.
You're new to GoToWebinar. Congratulations on learning new skills. And
I am. I do want to talk today and share where we are with thinking about Think. So we were thrilled with the program that we were putting together in San Francisco. The level of content, the level of expertise, the networking opportunities, really listening to our attendees from 2019 and taking a lot of the feedback and really putting it into play in new and different ways. So as things started to change in the world and as we began to understand how big some of the challenges were, we needed to quickly pivot our thoughts around Think. And so we are creating a Think digital event experience to be held the same days, May 5th through 7th. And so I said during my introduction that I'm passionate about face-to-face events. I'm quickly becoming passionate about how do you create as much value, right, for our clients and for our ecosystem of partners through a digital experience, right? And then making sure that everybody's understanding the true business value that comes with this. So we've had to shift our thinking and messaging around what is this? And one of the ways that we did that was we actually deconstructed the conference. So we thought about all of the different ways that people engage, right? Through the content, through the networking, through the demos, through the labs, the certifications, all of the value that comes from a face-to-face experience. And then we tried to say, what part of that can we make digital in a meaningful way? So I can tell you how we've done that. we are building the Think platform on Watson Media, delivered by the IBM Cloud, really to showcase the technologies live. And so when you think about it from a content perspective, what we called featured sessions. Featured sessions were the general sessions, so Arvind's session, Ginny's session, Jim Whitehurst's session. There were keynotes really around journey to the cloud and building a smarter business, trends and directions around all of the different areas across the portfolio, and then innovation talks. And these were outside speakers and luminaries talking about really powerful topics, right? Things around diversity and inclusion and good tech. All of that content will be captured and will be part of this experience. In addition to that, we had about 2,000 breakout sessions, both business breakouts as well as technical breakouts. We're taking 400 of those sessions and we're recording those, and they will be available as well. So here's what it looks like, right? You register, and you can register at ibm.com/think. It is a free digital event. And once you register on May 5th, you now have access to the platform. When you come into the platform, you'll have the main page, and that's what you see here on my screen with Arvind. And it essentially overviews the entire experience across all 13 channels. So you can quickly see what all the channels are about. You can switch between channels and consume the content live. And on each channel, there'll be Q&As and chat functions where IBM experts, right, are your peers, everybody will be participating in a chat function or asking technical questions through the Q&A during that live session. And we'll run content throughout the period, and then everything will be made available on demand. And we'll do this for all 3 days, May 5th, May 6th, and May 7th. And you'll see more information coming on our web as we finalize those 400 sessions, as we select the speakers and really are able to highlight how you can build a journey across the 3 days. We don't expect that anybody's going to sit in front of their computer for 3 days. So we're providing Watson powered and ways for you to go in and build your agenda across the 3 days. So you know what are the times that you want to pop in on each day. You know when you can go back, and then what kind of content you can consume on demand. The other thing we'll do is we know that our attendees are having chats where they like to live, right? Whether it's Reddit or Facebook or LinkedIn. And so we'll be staffing those and those channels where we know our attendees are. We'll be staffing there with SMEs as well to make sure that we're carrying on the conversation. Most of our speakers have made themselves available to be part of those chats and part of those Q&As. Another really powerful thing at our physical event was the ability for people to meet with executives one-on-one. And so we are taking that function, right? Requesting meetings, we're making that happen here, and the meetings themselves would happen with the executives via WebEx. So that will be taking place across all 3 days as well. So super excited. We are heads down planning. We are heads down making sure that we're building the right, most robust content, that we're capturing in meaningful ways, that we're staffing each one of the channels throughout the entire program with the right SMEs to engage in meaningful conversations. So lots more to come. Please keep checking our website, ibm.com/think, for more information. So with that, I think I'm going to pass it over to Aylee.
Well, you can pass it back to me, and I'm pretty excited about the channel surfing opportunity. That'll be just like home. You can change channels and surf. That's pretty exciting. All right, I'll make myself the presenter. And a little bit of news on upcoming shows. The 26th of March, SQL Performance Best Practices, especially for big data. That's with Dave Belke. And this show is, again, setting new records for registrations. A lot of people interested in SQL performance. 9th of April, we're going to have a show all about iDoug, which is still scheduled for June 7 to 11th in Dallas, Texas. Watch idoug.org website for news about the conference, and sign up early for your early bird discounts. 30th of April, DB2 11.5 news and updates with DB2's Chief Technical Architect, Carrie Romanova. So that'll be great. And we've got some more shows planned in May and June too, but I'm going to keep the suspense out there. Some of my favorite URLs to have everybody visit. If you haven't joined the IBM community yet, you probably want to do that. A lot of great conversations, news, events, all available there. Join the conversation, community.ibm.com. There's a new graphical user interface tool for DB2 called the DB2 Augmented Data Explorer. It's free. You can get it at the second URL. Of course, with today's show, we had to promote ibm.com/think. That's an online virtual event taking place May 5 through 7, as Colleen just said. DB2 Console, new tool, successor product to Data Server Manager. You can download it at ibm.biz/db2console. iiug.org. That's where to get all your information about Informix, news and events. idug.org. Again, register early and save. And a very cool tool that I'm excited about is the Watson Studio Auto AI. I saw a demo of it, and I'm going to play with it soon. And as long as I'm sequestered here at home, I might as well start tinkering with some new technology toys. Let's see, polling questions. Do we have any polling questions to ask? Select a poll. You plan to attend Think. Well, this will be interesting. I'd set this question up before the Think conference went virtual, but we'll ask our audience anyways. And certainly people can respond as if they're going to participate in the virtual edition of Think. We'll let 30 seconds elapse here for people to respond. I think with the conference now being free, no travel required, do it at home from your desk or your workspace if you're still going to work. Great way to get some free education. Going once, going twice, closing the polls and sharing the results. 41% responded yes. 29% are seeking approvals to participate. You still need to allocate the time amongst your work schedule for the days. And 29% said no, sorry, chained to my desk. They have other things to do. So that was interesting. Any other polling questions? Well, let's ask people if they learned how they heard about today's show. Did you learn about today's show on Twitter, LinkedIn, the DataView Show newsletter, our homepage, or the IBM community? If you are a recipient of our newsletter, thank you for being a subscriber. The mailing list for the DataView Show has now grown to well over 1,000 subscribers. That's very exciting. Okay, going once, going twice, closing the poll, sharing the results. So kind of a split between the IBM community and the DataView Show newsletter. Very few from the homepage. That's a little different. All right, so that's enough of that for now. Let's make Aylee the presenter. Is Austin arrived? Aylee?
Yes, Austin is here. Please make Austin the presenter. He's going to share my slides for me.
Okay, it looks like he hijacked your join link because I see two Aylees in my panelist room.
Oh,
I'm going to,
I did that.
Yeah, I'm going to go with the one that wasn't speaking. That might be Austin. Make present.
Great.
The other Aylee. So Austin, you should see a button there to make yourself the presenter.
I do not see that.
Yeah.
Oh, you sent it to me. It's the other Aylee.
Huh. Okay, let me try the other Aylee. How about that? Who's got the show my screen button? Is it Austin or the real Aylee?
It should be me. I'm I clicked it and it didn't. Can you just share it, Aylee? Sorry about this.
Yeah, give me 1 second. I don't actually have it pulled up.
Because I hit OK and it didn't pull up. So
Oh, one of those go to webinar screen sharing issues. You might have an Apple Mac. There's some kind of permission you've got to grant, whatever. This is why we always.
Okay.
So we'll now make the other Aylee.
Yeah.
Okay. Colleen, thank you for sharing that information about Think. And if any questions come from our audience, I'll get them out to you. Anybody got a screen for me to see? Oh.
I had to quit in order to give permissions to go to meeting. So you might have to share that with me just one more time.
Okay. We'll get through this. Back to Scott, and then Aylee, if you could speak again, I'm going to go with the Aylee that shows the active microphone.
Can you hear me now?
Can you hear me now? Okay, the one on the top.
That's me. All right. Now I can show my screen.
I can see your screen.
There we go.
You're doing great.
I got it.
Slideshow.
Slideshow.
From the beginning.
Play from start. There we go. We've done it.
Miss
Good job,
Aylee,
team.
you are awesome. Congratulations on your screen sharing achievement.
Thank you.
I should
Thank
send
you.
you a certificate.
Thank you. Yes, I'll be awaiting that eagerly in the mail.
So while
Okay,
everybody's
thank
home
you.
these days, this is a great opportunity to learn. Tell us about it.
Yeah, thank you everybody for your patience with the little technical difficulties we just had there. It's the joy of digital events. I mean, all events, right? AV is harder than AI. So I'm here to talk to you today about the IBM community. Thanks for sharing a little bit about that before, Scott, and also about a really interesting new event that we have coming up on AI explainability. And I want to thank everyone for joining us today, and I hope everyone is staying healthy and coping well under the current circumstances wherever you are in the world. My name, as we said, is Aylee Nielsen, and I manage the digital events program for the IBM community. Austin Eovito and I are here to talk to you today about that community and a number of free events that we've been doing digital events over at the IBM community for years now. So we're really excited for Think to Go Digital and for us to sort of test our chops out there, since we're not new to this game. First, I'm going to just give you a little bit more information on the IBM community for those of you who haven't heard of it or aren't members. You can join the IBM community and learn more at community.ibm.com. And it's a collaborative space for IBM users, which makes sharing your know-how and best practices on IBM products and IT interests really simple and fun. It's a place you can go to access the collective knowledge of thousands of peers across a multitude of interest areas and the areas that just matter most to you. And you can connect with the community via forums, blogs, resource library, and we have various networking groups and events, which is the portion of the community that I manage, digital events to be specific. We believe in bringing the community together through events with great people and fantastic content. And like I said, Austin and I have been working on cool new events to deliver the kind of content you guys are asking us for, our community members are asking us for, 100% in a 100% digital format and for free. So we will be talking to you today about the masterclass, the AI Explainability Masterclass and Hackathon, and generally about the topic of AI explainability. But I wanted to also share an event with you that we just completed that was really successful. Last week, we brought to you the Deploy AI Virtual Community Day. And you can get the replays of that event at ibm.biz/deployai-VC. And that event was created to support participants in exploring their personal journey to AI by creating opportunities for all of our members to learn from and talk to experts about what comes next in their own personal ladder to AI. We had over 3,000 people who participated in that event, and we had 33 speakers that covered 3 tracks, which were models and ops, AI infrastructure, and open source software. The replays of all of those talks are going to be available at that link I have up on the screen. Again, that's ibm.biz/deployai-VC, and they'll be available there for approximately the next 90 days. So go and check those out. We got tons of great feedback in our surveys we sent out to people who attended the event. They loved the content, brought a lot of value. So if that's something you're interested in, please go check it out. Again, 100% free. And now I'm going to throw it over to Austin. And Austin, since I'm controlling the slides, just give me a shout when you need me to flip to the next one, okay?
All right.
Awesome.
I put that URL in the chat for everybody to enjoy, and I'll also include that URL in the replay blog.
Yeah, and if anyone has any questions for me about the IBM community or any of the free events that we deliver, just put them in the chat, and I will get back around to them at the top before we close up the conference here.
Okay, Austin.
Awesome. Thanks, Scott. All right, so I'm good to go?
You are good to go.
All right, well, I hope everyone's happy and healthy right now with all the coronavirus stuff going on. And thank you very much, Scott, for giving me this opportunity. So today we are here to speak on explainability, which is a relatively large topic. It's a scientific topic, not necessarily just applicable to, AI and data science. But that being said, we will approach this from a data science lens, and we're going to talk about how you can apply, explainable workflows, and hopefully, produce more transparent and trustworthy results for you and your stakeholders. And so this first slide, it just kind of relays a lot of popular, statistical, literature that people have said. So, there's 3 kinds of lies. There's lies, damned lies, and statistics. That was popularized by Mark Twain. All models are wrong. Some are useful. But the one we're really focused on is, why did you do that? And anyone could say that, whether that's your end user and you work in the banking industry and you're working on, loan prediction algorithms. Your end user may ask, why was I rejected from a loan? Or you may be a data scientist working, in healthcare, and you're working on cancer diagnosis, and you need to speak to one of your oncologists about why was someone diagnosed with a tumor when they didn't have it. So that's really what we're trying to approach through this lens of explainability. Can you go to the next slide? Yeah, and so you guys are all here. So hopefully by the end of this talk, this graphic will make sense. To be clear, all of this content is pulled from the masterclass, which is what I'm here to promote. I'll point to the link at the end, but basically what this graphic is telling you is for this specific prediction. So this is an observation from our test set. We pass it into our explainable workflow, and basically we are able to look at what the algorithm would predict. And right here, we're able to see that we have 100%, our algorithm has 100% confidence that this specific observation should be classified as class 0. And the reason why is because when the value of Euribor 3M, which is a variable in our data set, has a value of less than 271, that contributes approximately 10% probability of that class being selected as class 0. We'll go into more detail of how this happens in scope of this talk. If you want a really good deep dive into why this works and how you can use it, that's when I recommend you go and use the masterclass, which is around 65 minutes long, and it takes you from data ingestion, basic feature engineering, visualization, and the end result being this graphic, as well as a few complementary statistics. Next slide. All right. And so something that I like to do is in the literature, since this is a relatively new topic, explainability, a lot of people use the words interpret and explainability interchangeably. So I thought one as a proof of concept to show you that they don't have the same definition. I put the Merriam-Webster dictionary definition of them, but the way we're going to view them is interpret is a static process, meaning that you as a data scientist or as an IT professional or software engineer, you do a series of tasks and then you obtain some kind of output. And what that output is an indicator of whether or not your process is going the way you think it is or it's not. And so what we call that static step is interpretation, which is your ability to diagnose and relay some information in a confined space. Can you go to the next slide? Explainability, conversely, is dynamic. Explainability is the idea of us codifying and creating a process of taking our interpretations and the underlying intuition that allowed us to arrive at these interpretations and making that transparent. So an example of this would be not simply describing to a stakeholder, oh, these are the series of algorithms and transforms we used, and this was the result. It really is, what is the underlying intuition? What were the assumptions we made about the data set that allowed us to pull these algorithms out of our toolbox? Because as someone who's a data scientist in practice and works with data scientists, as I'm sure a lot of you guys have seen, is sometimes you'll enter this space where it's very hard to translate how a technical project can be used in a business setting. So that's really what this is focused on, is making sure that you're creating trustworthy and transparent workflows that are actually creating applicable results for your business rather than just, isolated technology. So that's really what the paradigm is for this class. And we really try to, factor out our code in a way where you can hand this off to other data scientists, you can hand it off to different stakeholders in a variety of ways and make the important pieces of your content known immediately. And the way we do that is through some open source software like Lale, which is an IBM open source tool for semi-automated data science, and then AI Explainability 360, which is another IBM open source tool that includes 8 different explainability algorithms and then 2 different metrics. And we'll go over those in the next slides. Can you go next? Yeah, so simply put, what I just went over is this phrase. We define explainability as the ability for a data scientist or an IT professional results to be understood and interpreted by other data scientists and stakeholders. So the idea of this class really isn't to replace the data scientist versus it's to augment the data scientist's current skill set to reduce downstream troubleshooting. Because in practice, using the most complex algorithms just because they hold the state-of-the-art, accuracy score or what have you, may not be the most effective way of doing something. So I have examples of that, but since we're limited on time and scope, I would refer you to some of the blogs on the community that were written about this, or the masterclass itself, which will show you, key examples of where and when explainable data science should be used and where it shouldn't, because it is important to note that there are different thresholds for explainability. And what I mean by that is if you are creating a convolutional neural net that discriminates whether or not a cat or a dog is present in the picture, the threshold that you need that algorithm to be trustworthy and transparent is much more limited than some of the other more pertinent ones, such as autonomous vehicles or cancer diagnosis or loans, things of that nature. Another really interesting thing is to think about explainability under the guise of as someone who probably owns a smartphone, we all know that AI is used to serve us ads, but if you really stop and think, how did I get from the Grill Master Kohl grill to the new toothbrush? If you were to ping the company serving you ads and ask them, could they explain how they got from the Grill Master 3000 to toothbrushes, I think they would have a hard time explaining that. And that's what this workflow seeks to alleviate, is codify and factor in processes that alleviate some of these issues. That being said, explainability is not a panacea, and it is not a replacement for time and patience actually practicing this skill set. Can you go to the next slide, please? Yeah, and so here's a graphic that we made that kind of relays, the different stakeholders you may have in your traditional IT business. So the idea is starting with the second dot from the right, that's a data scientist. And the x-axis denotes experience, the y-axis denotes your technical skill, and the z-axis denotes the need. Need is the tricky one here. So need in this sense would be like the business context. I'm sure you've all woken up to an email where someone, a manager may say, I need this yesterday. That would be, extreme need versus, a coworker who asks for a favor would be no need. But with that being said, what we're able to do is basically we can plot our different kinds of personas on this, Cartesian coordinate, Cartesian plane. And what we're able to do there is we can kind of visualize, hey, we are going to have different users who have different needs and also have different backgrounds. And therefore, we need to try and make it conducive for them to understand what we're doing. Because a lot of the literature and the things you learn in data science tell you, you're a subject matter expert, you work with subject matter experts. A lot of the literature retains this idea that you're always going to be speaking to subject matter experts. So therefore, your write-ups, your code bases, your comments should be catered to that. Versus in reality, as a data scientist or IT professional, you'll be beholden to multiple different stakeholders, mostly being yourself, the data scientist, your team of other data scientists, your manager, regulators, depending on what sector of the business you're in, and the end user if you're using a product that can be used downstream. And as you can see, the technical experience of a data scientist and the end user is not the same, nor a regulator and a data scientist. So what this really does is you need to, and once again, this points back to the masterclass, but when you are defining your problem, the way I like to think about it is a well-prosed problem will yield a well-defined solution, and a poorly defined problem will yield a poorly defined solution. So when you are creating this well-defined problem and creating these different objectives that you and your team are going to strive to achieve, it's really good to keep in mind who's going to be using this. It might be multiple users, and you have to find a way, to meld those personas. But this is really just a way to kind of, relay the idea that you should be thinking through the code to how this will be used in reality versus just, the technical aspects of it. Sometimes teams can get bogged down in that. So next slide, please. Yeah, so this is a really brief example. Many of you may have seen this data set. It's a relatively good data set that a lot of people use for different toy problems, but it's a Portuguese banking data set from UCI. And what this is it's a marketing data set that has 20 different features, and then it has a Boolean dependent value, meaning that the Y value that we're looking for is either 0 or 1. And basically what we're trying to do is we're trying to classify these users based off of whether or not they opened a term with the bank or they didn't. And then we want to identify the principal factors that contribute to this classification. So an example of that would be the largest weight for the coefficient of our algorithm was the variable age. And that's something we could relay to our stakeholders. Hey, we found out we were able to build a classification algorithm with X accuracy, and this was the most pertinent feature. That's part of the answer when it comes to doing this in an explainable workflow. It's not the full stack, just because this talk was scoped to be a 30-minute talk. That stuff was removed for brevity, but once again, it's in the masterclass, which is totally free. And it's also codified in some other resources that I'll point you to in a few slides. Can you go to the next slide? Yeah, so I try not to put too much code in this just because it can become a little strenuous trying to go over it all. But really this code is LawLay code. It looks very similar to how you build pipelines in sklearn. That's actually something that was done on purpose when they built out this pipeline, is they wanted it to be very conducive for the sklearn model fit predict paradigm. And they also wanted to make sure that it played nicely with all the sklearn functions and operators, as well as the ability to wrap your own operators. And by operator, I mean, if you look at this first line, these horizontal bars denote choices. So logistic regression, horizontal bar, k-nearest neighbors, horizontal bar decision tree. And basically what that pipeline is doing is it makes it does a PCA. It concatenates the PCA with the regular data set, and then it basically automates the hyperparameter selection for each one of these algorithms, and it isolates which one is the best based off of that hyperparameter configuration. So we're able to test 3 different algorithms. We see that we can visualize our trained pipeline, and we do a PCA, concatenate features, and a decision tree ends up being the best algorithm. This is something that can be productized, but what this is really trying to point to is that explainability is iterative, and this is a very good format for prototyping different algorithms as well as different transforms. The pipelines can become nonlinear in nature and much more complicated. This is really just showing you guys what it can do right out of the box. And then, as you can see, we can print out our hyperparameters. That's in the second cell. And what we can do with that is we can export that as a YAML file, as a JSON file, and we can send that to other data scientists who could recreate our pipeline and pass the same exact hyperparameters. So long story short, LawLay is really built into this explainability paradigm, not to remove the data scientist from algorithm selection, but to give them back some of their time. So rather than having to manually test out and configure hyperparameters for these 3 different algorithms, we're able to, understand as a data scientist the assumptions each one of these algorithms makes, and configure a pipeline and see which one works best. The next step would be, manually configuring this pipeline to see if we're able to reproduce the results. And ultimately, we're able to get an accuracy of around 69%. Which is actually really good when the state of the art accuracy on this data set is 76%. And it also is important to note that we use directly interpretable algorithms, meaning that any of these algorithms you could look through and visually inspect and come to certain intuitions. K-nearest neighbors, you could look at your clusters. The tree, you could look at your split. The logistic regression, you could look at the visualization, or you could look at your logistic coefficients for your weights. So 69% straight out of the box with relatively humble algorithms. There's no XGBoost or SVMs or neural networks. We're able to produce, 6% away from state of the art. And, you know, we did it in 5 lines of code. You know, there's a lot of preceding steps that allowed us to get here, you know, making assumptions about the data set, things of that nature. But really, this is trying to show you guys how semi-automated data science could be used to alleviate some of these, some of the burdens of creating, you know, bespoke training modules for specific algorithms. Can you go to the next slide? Yeah, and so basically, once again, I don't want to show people too much code because it ends up detracting from the actual talk. This output is derived from the previous code you just saw. So basically, you import a function from AIX, which is a wrapper function, and you wrap your pipeline with that function, and you can produce these results. What's important to know is this is done through an algorithm called LIME. And what LIME does is it makes no assumptions about the underlying model it's trying to explain. So what's important to know is that the computations that occurred to get us these probabilities may not be the same computations our decision tree actually made. Once again, I can point you to the academic paper that describes this in more detail. But there's 2 metrics that I didn't include just for time. That are faithfulness and monotonicity that will indicate whether or not these explanations are good. In this case, the faithfulness and monotonicity metrics were satisfactory. I just didn't include them because it was a lot of code. But they're satisfactory in the sense that for this specific observation that we tried to predict the probabilities for, we were like 87% faithful, meaning, you know, 87% of model A, our original model, and model B, the model that computed these probabilities, was similar, and it was also monotonic. Monotonic is feature additivity, which means if you have 5 features, if you add feature 1 plus feature 2 plus feature 3, your objective function score should increase. So it means for each feature, for each added feature, the score you're trying to maximize should increase. If that condition is not met, then you don't have a monotonic function, and that indicates that you should probably go back and do some more feature engineering. So at this point, hopefully what you're kind of starting to understand is that this workflow and what we meant by codifying explainability is by following the steps associated with this pipeline, you're literally building in logical operators that allow you to quickly diagnose if assumptions are being violated or not. So it still requires, you know, expertise and intuition in the sense of understanding what these algorithms are actually doing, but it does alleviate some of the guesswork of why that algorithm works versus it doesn't. And once again, the masterclass goes into a lot more detail on this because it's an hour long. Can you go to the next slide, Aylee? This is the faithfulness and monotonicity metric. I just explained that. Yeah, so it's monotonic, non-faithful. Oh, so I got them switched. Yeah, so this one was not faithful. So the faithfulness, so they weren't similar. They had about 0% similarity, which means that the LIME algorithm did not do similar computations, but our features are monotonic, indicating that the algorithm makes use of each feature adequately, but we're not faithful. So the fix for this, reiterating, would probably be to remove the principal component analysis, just because that's where the trouble comes from. Because I know the answer to this problem, but yeah, so the PCA basically causes some non-stochastic problems, but that's a little bit more technical. But once again, that is codifying something. So it's the idea of, even though we're using interpretable algorithms, using a non-interpretable transform like PCA. So if you don't know, PCA is a principal component analysis, and what that is basically, the goal of it is to reduce dimensionality. So if you have a 20-dimensional data set, PCA, depending on the parameters you pass into it, would flatten that 20-dimensional data set into 2 dimensions. The problem with that is you lose your feature names, and also one of the assumptions you make is that all the variance of the models is captured in as few principal components as you can. Therefore, there may not be as many literal data points after a PCA as there were before, and that can cause some skews in the computations. But as you can see, so like we get these results, we interpret. I just kind of thought out loud, telling you what I think, and then I go back through, iterate again, and that process is what makes it quote unquote explainable. Versus if we just stopped here, we could say, we ran our code, we interpreted our results, but we can't really explain, fluctuations or changes in our model performance. Can you go to the next slide? And then so these are some research overviews. I really recommend these papers. So Stop Explaining Black Box Machine Learning Models. That's it's from a woman named Cynthia Rudin from Duke. I think it's a really well thought out and grounded research paper. She kind of makes the claim that, we should, rather than using explainable models rather than using explainable models to explain non-explainable models, she makes the claim that we should just use interpretable algorithms like CART, which is, one of the first decision trees, or use logistic regressions, things of that nature, or even, abandon some of these AI use cases and, use codified logical rule sets. So her paper is really good. It's from Duke. It's just a contrarian point of view. It does have some really good insights. So I'd recommend that one. Then you have the XAI program update from DARPA. I think it was a $10 billion research funding to Carnegie Mellon, UC Berkeley, and a few other schools. That's a cool one to look at. It'll point you to all the research that's going on around the US and the world. Why Should I Trust You? That's the Line paper. Type-driven automated learning. That's a paper from IBM with Lale. Towards Robust Interpretability with Self-Explaining Neural Nets. That's a really cool paper, pretty technical, really technical. It's from MIT. But it comes up into this idea of conceptual learning. So if you're into reinforcement learning and things of that nature, that's like explainability in deep neural networks, which is pretty cool. And then the last one's another IBM paper, which is TAD Teaching AI to Explain Decisions. And that's a pretty interesting paper of how you could apply some of these best practices. Next slide, please. Awesome. Yeah, so where the demos live. So there's an AIX 360 Bluemix page. It's at aix360.mybluemix.net. That's a really cool resource where you can kind of go through some of the demos they've built, versus their GitHub is more code oriented. That will show you, how do you replicate the demos that you saw from the Bluemix and build them out into your workflow. There's the Lale GitHub as well, with github.com/IBM/Lale. And then last but not least is our IBM Masterclass just launched on the 17th. So I'm really excited about that. And I hope you guys can learn something there. So that's at IBM-explainability.bemyapp.com. That also has a 6-week, so the class is approximately 65 minutes worth of content. And then there's a complimentary 6-week hackathon going on as well. So that ends April 24th. And there's an $8,000 prize pool for the top 3 winners for the hackathon. And what the hackathon is basically you take the skill set you learned from the masterclass, you find a data set, you'd find some kind of objective, solve for that objective, create a write-up, and then you submit it, and then ultimately we grade it and doll out the cash prizes on April 30th. You can go to the next slide. So this is the IBM Masterclass on Explainability. I just threw a picture in there so you guys knew it was a real thing, but once again, that link was what I just said. I mean, a lot of work went on there. A big shout out to Aylee for helping out, and some of our other internal supporters at IBM. A lot of work, but I hope you guys get a kick out of it. And then I think the last slide is my bibliography. Yeah, and so these are just some more resources. But that is all, unless anyone has any questions or anything of that nature.
Eileen, can we make a copy of a PDF of these slides available in the replay blog so that people have these resources and links?
Absolutely.
All right, send this presentation along to me and I'll PDF it.
Thank you, Scott. Appreciate that.
You are very welcome. Checking the question queue, and I don't see any questions popping in yet. Austin, you deserve the same opportunity as our other guests earlier in the show. Clearly, you're a very brilliant individual. Tell us a little more about yourself, personal hobbies, interests, family, something like that.
Okay, cool. Yeah, so so an interesting fact for me that I don't think a lot of people get to hear is I don't have a hometown. My dad's a US Marine, so I moved every year and a half. So the longest I ever lived anywhere was Okinawa, Japan for 4 years. So I came in at the end of your guys' talk, but I heard you guys talking about the beach, and I really miss Japanese beaches.
Awesome.
Interesting. You're our first homeless guest.
Yes.
All right, that's cool. Anything else, guys?
Not on my end. Thank you very much for this opportunity, Scott, and thank you to your guests for being here.
Yeah, I just want to thank everyone for joining as well and encourage everyone to go check out the masterclass. Austin put in some amazing work there. It's really interesting. The topic itself is really new and pretty cutting edge AI explainability, and we're really excited to bring you a hackathon on AI explainability. We can't find anything else like it out there. And again, also really excited to be able to offer that 8K prize pool. So make the most of your time working from home, everybody, and go ahead and check that stuff out. Thank you.
It's a great time to learn. All right, let's see. Make me the presenter. Show my screen. Yep, move along. We already asked if there's any questions, and that takes us to the end. So with a great deal of gratitude, thank you very much to our audience for being here. A live audience makes the shows more fun. Thank you, Colleen, Aylee, and Austin for being our guests today. Thank you, sponsors. The show is sponsored by the IBM community. And as always, you can find replays and show news at dataviewshow.com/news. And Stuart says, remember to wash your hands. Stuart is a very funny man. All right, and with that, the show is a wrap. Stay safe, stay healthy, and wash your hands. Have a good one. Bye, y'all.